In this video, we're looking at Exam 1, Section 2, number 1A. So, number 1, each of the parts in this problem asks us to consider the curve. The word curve is another name for graph. So consider the graph, or the curve, given by x y squared minus x cubed y equals 6. Now, this equation with x's and y's is not that easy to solve for y, so that we would just have a simple function of y in terms of x. That's not going to happen, but we implicitly have a function for y in terms of the x. There's this relationship between the x's and the y's. The relationship is whatever value of x you choose and whatever value of y you choose, you should be able to plug those values in and get 6. Clearly, not every point is going to do that. So the special points that do that are points that are on this curve. So we are going to use implicit differentiation in this problem. Here is what Part A asks us to do. Part A asks us to show that dy dx is equal to 3x squared y minus y squared over 2x y minus x cubed. So first of all, look at what this problem is asking us to do. It's asking us to show that something is true. This is great because it means that they're actually giving us the answer. We need only supply the work that gets us there, and we will be able to know whether or not we are doing it right if we can actually come up with what they're asking us to show that it is. So let's try doing this using implicit differentiation. First of all, I'm going to just write the problem down again. So I'm writing down this relationship. It's xy squared minus x cubed y is equal to 6. Let's go through this part by part and take the derivative of each of these terms. Keep in mind that y itself is some implicit function of x, so we'll need to use the chain rule when we get to the y's. Okay, first part. Let's take the derivative of xy squared. Well, this is x times y squared, so I'm thinking I'll need to use the product rule to begin with. So what is the derivative of just x? The derivative of just x is 1. So it's the derivative of just x times this y squared plus, now I can just write down the x, and I have to think, what is the derivative of y squared? Well, it's going to be 2y, and then 2 minus 1 is 1. But remember, y itself is some function of x, so I have to use the chain rule and multiply the 2y times the derivative of y. This is just this first term, the derivative of this first term. See, to do the derivative of this first term, we used the product rule across the whole thing, and right here we used the chain rule. Now we'll say minus, and we're going to take the derivative of this term of our equation. Again, we're going to need to use the product rule, and since I'm using the product rule, it's going to be the sum of two things. And so I'm concerned that I'm going to be trying to subtract the sum of two things, and so I carefully put in some brackets or parentheses to keep this subtraction straight and avoid making common mistakes. So to apply the product rule to x cubed times y, it's the derivative of the x cubed. Do you know the derivative of x cubed? Yes, that's 3x, and then the 3 minus 2 gives me, sorry, the 3 minus 1 gives me 2. So it's 3x squared times just the y. You see, the way the product rule works is you take the derivative of the first thing times the second thing, and then you add. It's just the first thing now, so this is just now x cubed times the derivative of the second thing. And the derivative of just y in this case is the derivative of y. That's right. So here is, inside of these brackets, is the derivative of x cubed y. Keeping in mind that y is some implicit function of x. Well, there's the derivative of the left-hand side of the equation. Let's take the derivative of the right-hand side. The right-hand side is just a constant. What is the derivative of the constant 6? It's just 0. Alright, well, in a way, all of the calculus is done. Now we have to solve for y prime and y prime. You know, maybe it's nice to, let's make sure everybody knows that when I talk about y prime, I'm talking about dy dx. That's the derivative of y with respect to x. If we can isolate this y prime, we will hopefully have shown what they asked us to show. This is now just using algebra. So let's try to isolate this y prime. Okay, I'm going to first just clean things up. 1 times y squared is y squared. Plus, this is x times 2y times y prime. I'll write that as 2xy, y prime. How about this subtraction sign? Let's distribute that negative sign. So this is minus 3x squared y minus x cubed times y prime. All of this equals 0. Now look at what we have on the left-hand side. On the left-hand side, we have some terms that have y primes in them, like this term and this term. And we have some terms that do not have any y primes in them. For example, this term and this term. Okay, the red underlined terms have y primes in them, and the green underlined terms do not. Let's move all of the terms that have a y prime to the left-hand side. Well, that's easy since they already are on the left-hand side. Let's move all of the terms that do not have y primes in them to the right-hand side. So this is, let's subtract a y squared from both sides. Right? This is 0 minus y squared, and let's this is minus 3x squared y, so its additive inverse is plus 3x squared y. So over here I'm adding plus 3x squared y, right? And what do we have? Okay, let's see what we have. So this goes away. I can bring down 2xy, y prime, minus x cubed y prime. This is equal to negative y squared plus 3x squared y. If you don't mind, on the right-hand side, I don't like how it's starting off with a negative value. I'll just rearrange this as 3x squared y minus y squared, right? These are both the same thing, right? And over here, this is still 2xy, y prime, minus x cubed, y prime. Now, look, both of these terms have the derivative of y in it. That was not an accident. We made that happen. We intentionally got all the terms that have the derivative of y onto the left-hand side. Everything that does not have a y prime in it was moved to the other side. And the reason that we did that was so that now we can factor out y prime. When we factor out the y prime, we get y prime times the quantity 2xy minus x cubed is equal to 3x squared y minus y squared. And look at the progress we have made. We had two different terms that have a y prime in it, and now we only have one y prime. To isolate this y prime, we will divide both sides by this quantity. We're dividing it by the quantity 2x y minus x cubed, and we'll do the same thing on this side. 2xy minus x cubed. So where are we now? Well, on the left-hand side, this goes. We now have y prime, which, by the way, is, of course, dy dx, is equal to 3x squared y minus y squared over 2xy minus x cubed. All right, well, let's hope that's what we were trying to show. Let's see. So here we are. Let's take a look back at what it is we were trying to find. We were trying to show, if you recall, this. Let's see what it says. It says we're to show that dy dx is equal to 3x squared y minus y squared over 2x y minus x cubed. And that is, let's see, that is exactly what we just did. 3x squared y minus y squared over 2xy minus x cubed. So, job well done.